Let's now start talking about logarithm functions, or commonly just called logs. All right, here's one case in math where I can easily give you the reason why we need to understand and learn about logs. Maybe you've had some exposure or worked with logs before. Sometimes logs can seem a bit confusing, but hopefully after you watch me explain how logs work, hopefully you will begin to see they're really not that difficult and they can be very important. So maybe I should put logs question mark. Why do we need to learn logs? Well, the last thing we talked about, we learned all about exponential functions. Exponential functions meaning that to do a very simple example, exponential functions are when you have your variable in the exponent of your number, or maybe both numbers. So here's an exponential equation. Now when we first started talking about exponential equations, we said one of the ways you can solve an exponential equation, and probably the easiest way, is if both exponents have the same base. Hopefully it's very obvious, this kind of problem, since the base is 2 on both exponents, or both exponential functions, the exponents have to be the same. And then also we talked about you might have a problem like this, where initially you see on the left-hand side you have a base of 2, and this is an exponential function. On the right-hand side, actually, it doesn't look like an exponential function at all. However, you realize that you can rewrite this as an exponential function with the base of 2. 16 is 2 to the 4th. So now we can rewrite this equation as 2 to the x to the 1 power equals 2 to the 4th. So now once again, since now we do have the same base, we can set the exponents equal to each other, and x would be 5. All right, so this is review. So sometimes if you're given an exponential, if you have an equation with an exponential function, if you can get the base on both sides of the equation to be the same, then you can solve it fairly easily. However, the problem we begin to have are equations like this, or equations like this. Here, 2 to the x equals 5. I want to solve for x. There's no way on the right-hand side I can rewrite 5 in the form of an exponential function with the base of 2. I'm sort of stuck. Same thing here. On the left-hand side, my base is 2. On the right-hand side, base is 7. They're not the same. Therefore, what do? I'm sort of stuck. Well, I like to say, since now we're stuck, the reason why God gave us logs is to solve these kinds of equations. Just as a sneak preview and just to start teaching about logs, let me actually solve both of these equations. Or they're really the same. Let me just solve this one. Here's what we would do. I'm going to go and I'm going to take the log of both sides of this equation. Now I'm going to do I'm going to solve this equation, and what I'm doing may not make any sense, and some of the words I use may not make sense, and I'm going to explain all that, but just to show you how logs help us solve this. I'm going to take the log, and I'm going to call this log base 2. I'll explain that in a minute. So log with a little 2 down here, log with a little 2 down here. Although actually, you know what I'm going to do? You're going to learn. There's a couple different ways to solve with using logs. I'm going to, just for now, not use the 2 here. Let's do this again. Actually, let's just take the log of both sides of this equation. Now, one of the very special properties of logs, which we're going to talk about later on, is if you have an exponential function inside the log. So this is log of 2 to the x. In some crazy way, what you can do is the exponent can now move in front of the log. You can see the whole reason why this is hard to solve, because I'm trying to solve for x, and like I've talked about before, right now the x is sort of stuck up in the exponent of this exponential function. It's like in order to solve this little equation here, I need to get at the x. But it's like the x is stuck up as an exponent. How do I get at it? Well, look what I just did. When I took the log of both sides of the equation, because of this special rule, and the rule says whenever you have an exponential function inside of a log, you can move the exponent out in front of the log. So now it's like I take the x as an exponent and I free it. I get it out of, I move it out of the exponent, and it's down here. And now I can solve for x. If I divide both sides by log 2, and later on you're going to see I can now go grab my calculator, and I can actually with my calculator determine what this is. Matter of fact, I'll just do it real quick. So log 5 divided by log 2, let me round it maybe to 3 decimal places. This is not an exact number, 2.322. And just for fun, we can see if that's correct. Here was our original equation, So I'm saying if I wanted to check my solution, if I plug in this number for x, if I did it correctly, this should be true. Is it true? We can actually do this calculation on our calculator. 2 y to the x 2.322, and you can see here 5.000. I had to round this off, so it's not an exact answer, but basically you can see, yeah, it equals 5. So that's the solution. So that's a very simple example of how logs allow us to solve an equation with an exponential function. All right, so now let's take the deep dive into logs and learn all kinds of things about logs and the different properties and what things mean. So this gives you the why. Now let's go in and become log experts. Let's first go through and talk about sort of some language and definitions. Let me just write out a little log expression here. The key thing I want you to realize here these are both examples of equations with the logs in them. In terms of the language, the number that is written, it's called the subscript right here and here. We call that the base. So if I was to read out loud this equation, I could say log base 10 of 100 equals 2. Log base 10 of 100 equals 2. This one I would say log base 2 of x equals 3. Log base 2 of x equals 3. So this number down here is called the base. So whenever you have a log, you have to also pronounce the base. Now, as in math, there are always special kinds of things. There are some special bases. As a matter of fact, this first one I wrote is a special base. So the first special base is base 10. Here's what happens when you have log base 10. Log base 10 has another name. It's also called the common log. I guess it's that way because log base 10 is the most common log that's used. Log base 10 is used a lot, more than any other base. So they call it a common log. It's sort of like when you learned algebra. What is this? Square root of 5 cube root of 7 fourth root of 20. So these are examples of radicals. And the root or the index is always this number right here. Although when we looked at this first one, it's like there's no number there. Well, there really is a number, right? We know this is the square root of 5. But in the world of math, since the square root is by far the most common radical, they decided, hey, every time we have a square root, we don't want to keep writing the 2 here. So from now on, the rule is going to be, if there's no root or index written here, then we know it's a 2 and it's a square root. You know what they do with common log or log base 10? They do the same thing. Since this is the most common log, most commonly used log, they will write it like this. You notice there's no number written here where the base is. If there's nothing there, then we know it's really log base 10. Or you'll oftentimes hear me say the common log. Common log and log base 10 mean the same thing. So actually, this first example I gave, you would actually never see this in a book, or probably in the rest of this class. You'll never see me write this, because if I want that, and this would be, I could say common log of 100 equals 2, or I could say log base 10 of 100 equals 2. When you're actually pronouncing it, it's okay to say both, common log or log base 10. But when you write it, you don't put the 10 here, you just leave it off. So that's our first special base. So from now on, if the base is 10, we don't write it, there's just nothing there. So how would I think about this equation? The common log of x equals 5, or log base 10 of x equals 5. This one would be log base 7 of x equals 5. So once again, when there's no number written there, there's really a 10 there. Now, in terms of definitions of special bases, there's one more, and this can sometimes cause students some problems, can be a little confusing. Do you remember back when we learned about exponential functions? Two is my base, e is my exponent, equals 10. And then we talked, and this is called this is an example of an exponential function. And then we did that crazy thing where instead of the 2, I can make my base e. Remember, e is that special number, 2.72 or something. I forget. I think 2.718 or whatever. And we call this the natural exponential function. Well, you know what we do now with logs? We use a lot here's an example. Log base e of x equals 20. And this e here is that same one. Remember, e is just a number. It's a special number, but it's just a number. Even though maybe you sometimes want to think or you forget and you think it might be a variable. It's not a variable, it's a number. So as we work with log functions, we can have our base not to be 10 or 7 or 2. Sometimes we will want to make the base e. Now when they do this, the math people decided not to call this log base e. In the same way over here, exponential function, when you have your base is e, they call it the natural exponential function. This is like a log equation. However, when my base is e, they want to call this a natural log. So this would be like a natural log equation. But beyond calling it natural log, you know what they do? They change the symbol. Instead of log base e, this log gets replaced by ln. ln means natural log. Sometimes when students are doing problems and they have a natural log problem, I tell them if they are starting to get confused or just in your mind, think of this as log AC. If that helps you to be able to figure out the problem. So now, in summary, there are two special bases right from the top. Whoops. The two special bases are log base 10 of x. We don't write log base 10, we just write log of x. And sometimes this will be called the common log of x. So if you hear me or someone else say common log, you know it's log base 10. And the other special log, log base e of x, you're not going to see it written that way. Instead, it's written this way, and we call this the natural log of x. All right, so that's some definitions of logs and some of the special logs. Now, the thing I want you to understand if I have the number 5, there's different mathematical functions I can do to numbers. For instance, I can take the square root of 5. Matter of fact, I could grab my calculator. They even give me a key, my square root key. So I can put in 5 square root 2.236. And I think most of us know what a square root means, right? 2.236 times 2.236 should equal 5. Sometimes I can take a number like this, 5, and I can square it. Although actually let's make it a little bit more interesting. How about 5.1 squared? Probably can't do that in your head. So you're taking a number and you're squaring it. Once again, if I wanted to figure out what that was, I would grab my calculator, 5.1, and here, the little button, x squared, 26.01. Well, what if I want to take the log of 5? Now this is common log. Log base 10, right? Because there's no base written here. Here's the important thing to realize. When you grab most calculators, right here, lo and behold, there's a log key, L-O-G. You have to understand, this log key right here is log base 10. Common log. So if I want to get common log of 5, log base 10 of 5, I enter 5 in my and I hit the log key. Looks like it's... So I want to emphasize to you now, log is a mathematical function that you perform on a number and you get an answer. Just like if I want to take a square root of 5, square root of a number, I get an answer. Or if I square something. If I take the common log of 5, it's just going to be a number. And I can use my calculator to determine it. What's also interesting, if we were asked to calculate the natural log of 5 on most of our calculators, matter of fact, it's right next to the log key. Here's a key that says LN. That stands for natural log. So our calculators also have a key to calculate natural logs. So if I want to calculate the natural log of 5, once again I enter 5, and now I hit my LN key, 1.61. Now here's what's interesting. Say that you were asked to determine log base 3 of 5. Well, most calculators, like my calculator, now there are some exceptions. Nowadays there may be sort of some fancy calculators, but most calculators, when you look at it, we have 2 log keys. Common log, log base 10, natural log. I'm needing to take log base 3. I don't have a key on my calculator to be able to figure out log base 3. And most of you, if you look at your calculators, you will not either have, in this case, like log base 3. But I will say that there are some fancier calculators that I've had students in class who now say that their calculators can do this kind of calculation. But for the rest of us, what do I do if I'm asked to calculate this? So I'm going to jump ahead. You won't have any problems like this in this immediate module, but you will eventually have some in the next homework or two. We have a little, it's almost like a formula. It's called change of base. So let me explain the change of base, and then we'll finish out this video and start the next one. So let's do change of base. Because the idea is, if I have common log of 5 or natural log of 5, I can grab my calculator and I can figure out the answer. But when I have log base 3 of 5, I'm sort of stuck. My calculator cannot help me. You know what I would like to do if possible? I would like to change the base. I'm given log base 3. I don't want base 3. Matter of fact, I would prefer if I had base 10 or even the natural log, base e. Either one of those, my calculator can help me. Well, change of base gives us a way to do just what it says. It changes the base. So in other words, what I really want, I've got this little problem, log base 3 of 5. Somehow, I wish I could change this to log base 10. Because if I could do that, then I could go grab my calculator. And change of base allows us to do that. Change of base says, you got a log with a base you don't like? Fine. Use the change of base, and you can change the base to whatever you want. So here's a little formula. I'll call this log base A. We're taking log base A of B. What you do is, change of base says, I'm going to write a fraction here, log on the top and log on the bottom. Now this fraction and these two logs, I can choose whatever base I want for these two logs. It has to be the same base for both the top and the bottom, but I can choose my base. As a matter of fact, I'm going to write 10 here, although I've told you we don't do that. But just to make it clear what's going on, I'm going to make the top and the bottom log base 10, which is what I like. And what you do is, the number inside the log goes right here, and my original base goes in the bottom. Let me do this example here. So this is a formula. Formulas can be confusing sometimes. Let's do an actual example, and you'll see it's not very hard. Log base 3 of 5, I'm sort of stuck. I can't use my calculator. However, if I can change the base to base 10 or natural log, I can do it. So these are both. I'm going to leave off the bases. So these are common log. These are log base 10, top and bottom. I put the 5 in the top and the 3 down here. And now I can actually calculate this with my calculator, because this is log base 10 of 5 divided by log base 10 of 3. So with my calculator, I'll do the top first, 5. I hit my log key. Then I say I'm going to divide 3 and my log key. And lo and behold, log base 3 of 5 equals 1.46. So now, I can use my calculator to do any kind of log calculation I want to. If I'm given a base that's not base 10 or base E, I can always use the change of base, and the change of base is a pretty simple formula. Just for fun, Since my calculator has two log keys, log base 10, natural log, I could have also, I chose here, when I changed my base, I went from base 3 to base 10. I could have gone from base 3 to natural log. And now if I do this calculation, I should get the exact same number. So now 5 natural log divided by 3 natural log 1.46. All right, so that was a little, we sort of jumped ahead by explaining change of base, but it makes sense to do it right here, and it's not that hard, so from now on, when we get to it, we'll have already covered it. All right, in the next video, we're going to continue to learn about logs and learn one of the very important topics with logs, and that's how if you're given an exponential function, you can rewrite it as a log function and vice versa. If you're given a log function, you can rewrite that as an exponential function. So this is one of the key things to understand when we're learning about logs. So we'll talk about that on the next video.